Hi, so today we're going to start talking about a programming language called C++. This one is really to just get you started on understanding computers. How do they work? What are these machines? They do work like a machine. And what are these different programming languages? To understand the word compiler and what that means. And then hopefully soon we will compile and run a C++ program and then start to understand, well, when we run programs, we get errors. We want to plan our programs, so we're going to talk a little bit about algorithms and what is programming. Computers carry out these wide range of tasks because they execute these different programs, each of which instructs the computer to work on these tasks. So this machine stores data, does things that you ask it to, and then executes these programs. They can run large amounts of data, do complex computations, all kinds of different things. Basically, a computer program tells a computer what to do. There's hardware, there's software that is involved in all of this. The programming itself is writing these and designing and implementing these computer programs. So what does it start with? This CPU, the central processing unit, is basically this core of what performs all of the operations that you do. Something you probably never look at, but it's important to understand. It carries out these operations. Everything travels through the CPU. You have memory. There is this memory that is happening when you're actually running the program, this random access memory. But there are also memory that is stored in some way, shape, or form. Disk drives are probably on a thumb drive now. How much memory your computer has helps you understand how well it can process and how fast it can process. You're the writer, you're the user. You're going to have input, you're going to have output, because otherwise why would it be terribly useful? We're going to start with keyboards and your monitor, nothing too fancy. We'll get to some files and things like that as we go along. So what's happening inside? Just so you sort of understand, you've got a keyboard, you're giving it a mouse, you're giving it some information. We have CPUs and this RAM. Things are getting processed. They call it on a bus. And so all of this stuff has to get tied together in all of these different parts and work into a machine. So let's kind of just take a look. Wait a minute. What's that? Well, that's what a computer used to look like. A big, huge machine that took up a whole room and things were plugged in and plugged out. Computers still work the same way as that old machine, but they are just smaller and faster. The actual operations are not all that different. Computers have to think the way they think. Yep, that's one computer called the ENIAC. Now we have to think about, how does the machine do what we ask it to do? There are machine instructions that tell the machine what to do to actually process things and move things and make decisions, etc. They're encoded and sort of stored in a Pentium processor, any processor really, Pentium being the most current one. It's encoded, and then the processor figures out what to do with it. Every processor works a little differently. That's why some are considered better than others. Now we're going to talk about a high-level language, C++. They're independent. We don't care about the processor and the hardware. The compiler takes that high-level language and translates it into something that the processor can understand for whatever specific CPU we're using. So there's a whole lot going on in the background. How did this all happen? Well, pre-1972 seems like ancient history. A language was developed called C. He added features and it resulted in C++. It has been revised. It's a general purpose language. It's used quite widely and it's used in lots of operating systems. So future might have a different standard. You'll hear about lots of languages, but C and C++ are still the basis of almost all general purpose programming. Now, how do you do it? Well, you're going to get a programming environment, a C++ environment, or an IDE. This is similar to the one you're going to use. It's a little bit different, but the idea is you will have a place on the computer where you're going to program, and we'll see that in class. This is your source code, which is basically done in an editor, but it's enhanced a little bit. As you can see, it has colors to help you identify what's going on. When you compile, you'll get a message that says, it ran, or you have errors down below. And they're all similar to this. Now, there's a lot going on behind. What happens? You write it into that source file with the editor. It gets compiled, translated into machine code. There are some other things like libraries that are needed. Those are linked together, and then it executes the program. That's that exe, that final program that comes out is executable. So it combines all those things together. This is a flowchart. You're going to see more of this, but it basically reports on how it works. So the flowchart says, yep, go through a program. If there are no errors, then you go on. And if there are no runtime errors, you go on and it runs. If you get any errors, it goes back and you have to fix it. Every program has to have a main function. Oftentimes we're going to talk about functions later. So how do we get errors already? Talking about errors, errors are really common when you program. One of the errors that's common is that C++ has controlled words like main and they're case sensitive. But if you say that with the capital M, it won't link, it won't work. It can't find a main function because it's not the name that it's supposed to be. So everything has to have a main, a little m. Okay, so what's an algorithm? Why did I talk about those? Basically, it's a recipe. It's a step-by-step process that you go through. So for example, when you're writing a program, you figure out what is the problem. You first plan an algorithm, a step-by-step problem. You test it, you translate it into your code, and then you compile and test your program. So algorithms tell us steps to go through. I like to use flowcharts like you've seen so far, and we're going to talk about those more. Pseudocode is another way to do it. It's basically easy to understand language, but that can be easily translated. It shows in logical steps the process, and we call it pseudocode because it's not code yet. When you're doing this with a flowchart or pseudocode, it has to be unambiguous, precise instructions of what happens. Here, next, it has to be executable, meaning it has a start and finish. You can actually execute it. It can be carried out, and there's that finish. It has to come to an end. So let's just talk about what pseudocode might look like. For example, you're thinking of buying a car. One's more efficient than the other, right? We want to take a look. You look at price and fuel efficiency. You think about how long will you keep it. $4 per gallon, 15,000 miles per year. You're going to pay cash, not worry about financing. So which car should you buy? So you put some data together. What's the algorithm? Well, what are my inputs and my outputs? Purchase price, fuel efficiency for both. Okay, we need an output. What is the output? Which car is the better buy? That's the desired output. So we break it into smaller tasks. What will we do for each car? So total cost, so purchase price, operating costs. 10 years, we make it annual, so price per gallon times the amount of fuel consumed per year. Annual miles driven divided by the fuel efficiency. We put that all together. We compute the total cost. And then we say, well, which total cost was better? And we arrange it. So this becomes a pseudocode. And then you work a problem. Work your pseudocode with an example. Here's my two examples. Calculate the total cost. First one was $37,000, second one $40,000. Choose the first car. So that's the idea of algorithms, of stepping through step by step. So we've described a computer program, started to understand what its components, an actual computer's programs, computer is, and then we talked a little bit about how it works, and then we started talking about the environment and what happens there, and then thinking about how do we make a program. So here's a couple of little things. We haven't talked about most of these things in the cout statement yet, but we did talk about pseudocode for simple algorithms, and then what are some errors that you could run into. And